Hello explorers and welcome to another video. Today we are going to do more Advent of Code. This is my time off. This is what I like to do, what I think is fun to do. I've done a lot at work and got a lot done with problem solving, and this is less stressful problem solving and more fun problem solving. So what do we have in store today? This is day 3 and this is the toboggan trajectory. So this is the way we will run our toboggan. And with the toboggan login problems solved, you set off towards the airport, which while travel to the toboggan might be easy, it's certainly not safe. There's a very minimal steering in the area is covered with trees. You need to see which angles will make you near the fewest trees. Due to the local geology, trees will in this area will only grow on exact integer coordinates in a grid, and you make a map, your puzzle input, of the open squares, which are the dots, and trees, which are the brackets that you can see. No brackets, it's yeah, I don't remember. And these are the only trees though, due to something you read about once involving arboreal genetics and biome stability. The same pattern repeats to the right many times. So you start at on the open square in the top left corner and need to reach the bottom below the bottommost row of the map. The toboggan only follows a specific slope. You're opted for a cheaper model that prefers rational numbers, starting by counting all trees you will encounter for the slope. Right 3, down 1. From your starting position at the top left, check the position that is right 3 and down 1, and then check the position right 3 and down 1 from there until you get past the bottom of the map. The locations you check in the above example are marked in X here, and O's is where there are open space, and X are where there was trees. As you see here, this trajectory, and in this example, traversing the map in this slope cause you to encounter 7 trees. Starting at the top left corner of your map, you're following the slope right 3, down 1. How many trees will you encounter? Okay, so this is the first puzzle input that we have. So let's say that we have that set up in a way. So we switch over to our development environment here. See, there we have it. So this is the real puzzle input, but we can have a file called puzzle 3 test.txt. So this is the test input. So we know that this will give us 7 trees. So if we can solve this one, we should be able to solve the real one later on. So first off, we need to create a class here. Let's do the puzzle 3A. If we need to do another one for the B puzzle or the second puzzle, I will do that. We create a main function. And then we will copy some read logic from the earlier example yesterday. And I think we should keep this string input here. We should have the try catch statement. I think that's a good thing to have. I think we can copy that as well. It's pretty much keep everything. We just don't need this valid puzzle here. String bug. So we have all those features already in there. And on this line, we take the inputs and add the line to it. So now we know how many lines there are, and we can create our integer forest. And there might be something else in the integer forest, so I will say that the open spaces are zeros and the trees are ones inside of an int array. And this array we will create with just int. I wonder if we need to have a forest. Perhaps it's easier to have a forest class. Let's do that. Forest, like that. And forest. New forest. Like that. And that takes the inputs. And then my logic here would be something like we have forest, and then we want to move 3 to the left and 1 down. And while we can do that, we want to do that, and in this we want to 3's 0 forest check it has 3. So if that's true, so 3's are plus equal to has 3's 1 or 0. So we have two functions here. First off, we have the forest. We have something that we want to parse here in the forest class. So we get all the inputs into our int array. Then we want to have something that can move within that int array in a specific direction. And then we want to check if there is a tree in that specific position in our class. And if so, we will return true, else we return false, and those are interpreted as incrementing 1 or doing nothing. So let's create these different functions here. Inside of this, we can give this an x and a y coordinate, so we know in which direction we want to move. And then we will have an int map up here, the private int map. And the int map should be the inputs. Let's see here. Inputs, if inputs is empty, throw exception, no map. So that's not okay. But otherwise, if we have a map, we will check the inputs size and time that with the inputs the first value's length. So that's our map is equal to new int array of that. So then we will have a bunch of integer values that is the size of our map. Then we will, in this case here, not move here. So we will actually need to have private int x private int y. Can call them pos to the position, and we set those to 0. And here we take pos x, increment that by x, and pos y, increment that by y. And we need to have more functionality here because we need to check that it's actually okay to do that. So if pos y is larger than, that's what we want to return. If pos y is less than the inputs, okay. So I think it's easiest to save the number of the size of the map here. So map max x and max y. I will make those final as well because we will set those in the constructor. Max x is equal to the length of the first input because all of them will be the same, and max y is equal to the input size. That's the number of rows. Max y times max x. That's our map. And if the position is less than max y, then it's okay. And here, if pos x is equal to if pos x is larger than max x, then it's equal to pos x minus max x. So we will start from the beginning, else it's equal to pos x. So we will keep that value. So that's what we want to do in order to ensure that we are inside of the map. We haven't parsed the map yet, but we're just doing the rest of the logic because that's easier to think about at the moment. So we can do the other ones later on. So now we want to know if the current position has a tree or not. So then we will have the map, and we will get the pos y times the max x plus the pos x, and we will return true if that's equal to 1. So then we know that there is a tree there, and this is just to say that we want the row that is that current row. And if you are having the current position of y, if it's 0, then it's the first row, and you don't need to increment anything. Otherwise, you will increment the size of each row in order to get the current position within the larger map. And up here, it doesn't really matter which way we put these. We just need to have a map that is the sum of all those. So we have max y is the number of rows that we have. So we have the number of rows times the size of the rows. So now we need to go through all the inputs and add values. So for each string as inputs, there we get the input strings, and then we want to have all the characters in the string. So I think the easiest way to do that is to get char array, and for each character in the char array. We want to do something, and we can do a system out print line. And I think here the move here. Yeah, the move should be falsy directly, right? We will see. So let's just print this C variable here and see if that's something we can or want to do. Debug. Yeah, it's not initialized. I had that problem yesterday as well. And we run this. Let's see if it... Yeah, so we will get some values here, but we don't have the right puzzle input. So 3 test text. Let's see if we get the right values then. Yeah, we get a bunch of these different values here. And I want to say one more thing about yesterday's puzzle, because I got a lot of really good suggestions to this. So I've done some small changes to this password here. First off, I think Aaron asked me if we couldn't use a regular expression, and he had used that in his Python code. And I thought that was a brilliant idea, so I actually changed it up to have one regular expression where I take a digit, another digit, and then 2 strings over here, and just get the groups if I get something that I find. And it works perfectly well. And then I had another suggestion that we should look into having using an XOR down here instead, so one of the values are correct and the other one is not, and that spared us a bunch of code as well. So this is another way you can check that one is equal but not the other. So really good suggestions, and keep them coming, and read all the comments. I really like when you have good inputs to things that I do. So let's continue here into the forest. So this, if we have a C character that is equal to this thing here, then we will take this map, and I think we can actually just have an integer iterator here that we just add to up here, and then we will just put that into here. That should be just okay. So I'm not really sure what happened to my keys here, because it seems that the Alt key is triggered in some way, so I can't really do mark multiple lines. So I'm not really sure why that's stuck here, but okay. Let's see. If we run that, then we should have yeah, it runs through at least. And I think here we can do 3's is out. Also some suggestion from the chat that the easy way to get system out, that you type the variable that you want to output and then .s out, and that will in turn, if you press tab, give you a system out of that variable in IntelliJ. So that's a really simple and sweet way to get that to work. So let's see here. Then we get 7. And that was what we wanted to get with the puzzle test input. So it seems like we actually created something that works here. Let's try with the real input and see how many trees we get then. 227. So that's a lot. Hopefully that's correct. Let's try. 227. Submit that. Not the right answer. It's too low. if you got stuck, you can try again. So let's return. So what did we do wrong here? We got the right for the simple input. That was 7 trees. But we didn't get it right for the larger input. So, yeah, and I'm back. And I didn't really solve this one today. I have been thinking a lot about how to visualize this, and it's harder than it looks. I think I could actually type out the map multiple times in a sequence or something like that, and then put the X and O's in it to see if I can figure out what I've done wrong. But I think I will leave it here, and then you can come with suggestions of what I might have been doing wrong here. The code is, of course, in the link in the description down below. So just look at that and give me suggestions how to improve this code. I think it's pretty easy, this code to follow, and I think it's logically correct. But I obviously did something wrong here. But I can't really I can't really see it. So it's always good to have more people look at your code and give you suggestions. So please do that. I hope that you liked this video anyway. Perhaps you learned something today. If you have any suggestions, as I said, leave them in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. And if you haven't subscribed yet, please do that. If we figure this one out, I will do an update video for this one. And I really hope to see you in the next video.